Okay, so in this video, I'm going to briefly introduce an analogy to give you a little more context of what electric field really means and how it relates to charge. And that analogy is going to be water. And I'm going to be using an analogy to water a number of times through this course, as it tends to be helpful because water is something you can see, you have an understanding of how it flows, and electric fields we don't really see. We just sort of mathematically describe them as being there. And so sometimes water is a very helpful way to describe this. And so what I want you to think of is that positive and negative charges are basically sources and sinks, right? So anytime it's a positive charge, it by definition is spewing out electric fields at a constant rate, or really that it's sort of spewing out water. Negative charges are going to be analogized to drains, which means that they are sucking in water at a certain defined rate. The bigger that charge is, the faster it's sucking in water or spewing out water accordingly. So that's how positive and negative charges relate to each other. Taken from that perspective, electric field lines can be thought of as the flow of where the water is going, right? So if I have a big tub, and on one side of the tub, I've got a hose that's spewing out water. On the other side of the tub, I've got a drain. Ask yourself the question of where the water is going to be flowing. If I place my finger somewhere, or I place a little small piece of the leaf on the surface, where's that leaf going to go? That's going to give you an idea of where the electric fields are going to be. Now, to be truthful, this is technically electric flux, not electric fields, and we're going to get to that later. Electric fields and flux are very closely related, but I'm introducing this now because it still gives you a pretty good intuition for what electric fields are. And so if we think about a source that's spewing out water and a sink that's sucking in water, it makes sense that the flow lines of water would basically look like this diagram over here. And this is a field diagram, so we can describe what the fields are at any location. And when we look at a field diagram like this, I can pick any location, and at that location, the electric field line is just going to be whatever line flows over that point in that direction. The more densely packed the lines are, the higher the intensity of the electric field is, and the actual direction tells us where the field line is actually pointing. So this is a nice analogy. It's going to be sort of helpful. This one should hopefully make sense. This is called an electric dipole, right? And it certainly makes sense that water ought to flow from the source toward the drain, where it's going to be drained away. And any water that happens to be forced away from the drain is probably eventually going to be sucked in toward the drain. Sorry, water forced away from the source, right? And so that's kind of a helpful analogy. And you can sort of use this to intuit your way toward the electric field configurations from different structures. So for example, let's say we had a positive charge over here and another positive charge over there. All right, so you got a tub and you've got two different hoses plugged, pressed down into the tub, and both of those are spewing out water at a constant rate. Right, so the water can come out from the tub or from the hoses, and both of those hoses are spewing out water. But when in the middle, in between these two sources, these two flow of water are going to run into each other, and so they can't effectively overlap. They're sort of going to push each other in opposite directions. And so what ends up happening is this water is going to kind of flow up here to get away from that other source, and this one's going to flow up there, and so on. So you end up with field lines that kind of look like this. And it turns out this actually does describe the electric field lines that you would get from a configuration like this, where you've got two charges that are near each other. This doesn't include the fact that these two charges are also exerting a force on each other. They're repelling each other. And that should kind of make sense, because you can almost look at it like, the water that has been pushed out from each of these sources are pushing against each other, right? And so they're pushing each other apart because they don't want to come together. And to some extent, that's what's going on, and that's part of why these positive charges end up repelling each other, whereas a positive and a negative charge are sort of sucked in, together. All right, so that should give you a bit of an intuition about how electric field lines work on a qualitative level. And the next section, we're going to talk about some specific examples of the electric field for some real distributions of charges.